In the previous chapter we talked about the corresponding angles theorem, and this theorem said that if we have two lines that are parallel, then the corresponding angles have to be congruent. Well, this next theorem is very similar to that, except now we're going to talk about the converse of the corresponding angles theorem. And what that says is that if we have, sorry about the different colour there, if we have two lines like this where the corresponding angles are congruent, then that means these two lines have to be parallel. So you can see why that's the converse. And what might we use this for? Well, we would use this to do something like the following. You might be told that this angle here is 2x plus 10, and that this angle down here is 3x minus 55. And I might say, if x equals 65, can you prove that the lines are parallel? So what we have to do is we have to plug in x equals 65 to each of these and see what happens. So first of all, 2 times 65 plus 10, excuse me, that's going to equal, well, 2 times 65 is 130 plus 10, that's going to equal 140. Now let's do the same thing with 3x minus 55. 3 times 65 minus 55, and that is going to be, oh yikes, 130, 195, that's going to be what, 195 minus 55, and that's going to give us 140. So we've just shown that this angle here is the same as this angle here, and you'll notice both of those are corresponding angles, so therefore we can use the converse of the corresponding angles theorem to say that since the corresponding angles are congruent, then the lines are parallel. Let's review three other theorems that we learned previously, and one of them is the alternate interior angles theorem. And this one said that if the lines are parallel, then the alternate interior angles have to be congruent. And the alternate interior angles were these two right here. So in this case, since the lines are parallel, those two angles have to be congruent. We also had the alternate exterior angles theorem, and that one said if the lines are parallel, which they are, then the alternate exterior angles are also congruent. And then the last one, you have to be real careful with this one. Same side interior angles theorem. Well, these two are same side interior, and it should be very clear to you to see that they are not congruent, but this theorem said if the lines are parallel, then these two angles here and here have to add up to 180. So let's talk about what the converse of each of these theorems say, and it's pretty simple. Just like the converse of the corresponding angles theorem, if we tag on a converse here and a converse here and a converse here, let's start off with the first one. All it's saying is that, let me just get rid of that. Okay, converse of the alternate interior angles theorem says if the alternate interior angles, which are, let's say, here and here, if they are congruent, then the lines must be parallel. So that's pretty simple, just like the last theorem. The middle one says the converse of the alternate exterior angles theorem. So if the exterior angles are congruent, then the lines must be parallel. And then finally is the same side one. Whoops, didn't want to do that, did I? Yikes. Let me just try and draw that picture a little bit there. So the converse of the same side interior angles theorem says that if this angle right here and this angle right here add up to 180, then the lines must be parallel. If you're lucky on the test, you might get asked a question like this. that will say something like angle 5 and angle 4 are congruent. Which theorem can we use to show that the lines must be parallel? Well, angle 5 is here and angle 4 is here. So what kind of angles are they? Well, they are alternate interior. So to prove that the lines are parallel, then it's this one right here, the converse of the alternate interior angles theorem. So let's try another one. How about if this time we choose the angles, I don't know, angles 1 and 8. If those angles are congruent, then which theorem proves that the lines are parallel? Well, 1 and 8 is here and here. They are alternate exterior, so the reason the lines are parallel is by the converse of the alternate exterior angles theorem. You always have to remember that whenever we're proving lines parallel, it's always going to be converse of. Don't forget that, very important.